Good morning, ladies and gentlemen. Do this now. Read page 418 to 419 in the Reg Phys book. So 418, starting here with concave mirrors. Blah, 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 blah.
And that's it?
And that's it, yeah. Okay. So concave mirrors. It's all about concave mirrors today. So concave mirror. So observations. We played with the concave mirror last time we were together, right?
Yeah.
And here's our concave mirror. Lovely, lovely indeed. I'm gonna put it right here for us, like last time. And when we're at arm's length, which we'll say is right here, what do we observe?
Well, you're upside down for one thing,
I'm upside down.
and you look smaller than you are.
Yeah, and then as I get closer, whoa,
You're getting bigger.
whoa, I'm getting bigger, right?
Bigger.
Okay, I'm getting bigger, and then at some point we can no longer see me.
You gotta bend your knees here. There you go. There you are.
Ah, there I am. Okay,
Now you're bigger.
You can't see me. Kind of. Okay, right here. Okay, so difficulty seeing me, and then at some point, oh, my voice is getting louder. When I get very close, now I'm getting smaller again as I get closer, and I'm upright.
Yeah.
Right? Okay. So there are some things happening here. You can observe them. You can see them. Today we're going to talk about how we can actually get them using a diagram. Okay. So we're also going to if we can let that paper go. Use the homework. All right. Let's see if I can do this. Probably should have practiced. I see something. You see something?
Well,
Ah ha ha! You see it?
yeah. The physics, the arrow is upside down, and the word physics is backwards. So the mirror is forming an image on the screen. Oh yeah, you can see it. There's physics, and its physics is backwards and upside down. So that's the image
yeah.
produced by this concave mirror.
Cool. Mirrors for images. I think that's what you labeled this lesson, Logan.
Yep.
Brilliant. Okay. So mirrors form images. Boom. The image can be the same or different size than the object.
Yeah, and we saw that a moment ago.
We saw it with the mirror, and then remember our Get Real lab when we had the letter L for love, we love physics, and how when we moved, the mirror.
We changed the distance between
Yeah.
the mirror and the object.
The L got bigger and smaller, right? And so
Yeah.
we see that. Okay. Mirrors can be flat, convex, or concave.
Here's a spoon. That's the outside, and that's the inside. The outside, the inside.
This looks like a girl I played basketball with. Okay, so mirrors can be flat. We dealt with the flat mirrors already, right? The plane mirrors.
Yep.
And our image was located behind the mirror, right?
Yep.
It wasn't real, it was virtual. We're not really going to do as much with convex mirrors.
Convex mirrors are the ones up in the corner at 7-Eleven to make sure you're not stealing the Snickers bar.
Yeah, so we're not going to really deal with those. We're gonna be focusing on concave mirrors.
Concaves are much more interesting. They form images, real images, and that can be projected on screens.
Yeah, so changing the distance between the object and the mirror changes the distance from the mirror to the image. Okay, so changing the distance of the object, so if the object is here, and if I move it back to here on this point, then I'm also going to change the distance from the mirror to the image. So as it's here, the image is here.
Yeah.
As I move my object back, this one moves front. So I'm changing the image. When I change the distance of the object between the mirror,
Yeah.
then the image is going to change as well. There's a relationship.
Yes,
there.
ma'am. And all distances are measured from the mirror.
Yes. From the mirror, people. Okay. So spherical concave mirrors are a part of a sphere. Okay,
We have a
so
sphere here.
Here's a sphere. Sphere here. Okay. And this, if you slice off a piece of the sphere right here, this could be like what our concave mirror is over there.
That's right.
Right? It's like the missing piece right there.
Yeah, so it's part of a sphere. It's got a curve. It's got a center down in there somewhere.
Yeah. This bad boy right there.
Yeah, hang on a second.
Looking good?
That's better.
Okay. All right. The line from the center of the sphere to the center of the mirror is called the principal axis. Okay, so center of the sphere, which is right in there, you see it? Right there.
Yeah, it's down in there.
Yeah, to the mirror, which would be like right here, right? We call that the principal axis.
So it's like this would be a very large sphere, but from the center of the mirror to the center of the sphere would be the principal axis. And if you go back, can you go back to those illustrations we saw a minute?
This one
These.
here? Yeah.
So this would be the principal axis right there.
And then the center is that C right there.
Yep.
Right?
C.
We give it a label. And done with that part.
Okay, so now we go outside.
Yeah, I was like, we think we have something going on here. Okay, so follow me. Alright, so concave mirror.
And look
piece
at the
of wood.
shadows you're making.
Yeah, okay, right here. Alright, so here's the sun, right? Okay, let's see if we can focus it a bit here.
She's changing the distance.
Oh, okay, not as
Boom.
in focus. Oh, right there? Yeah. Oh, no. So now
Too big.
oh, gosh, it's really bright. Okay, right there. You guys see the sun?
Yeah.
It's so cute. Okay. All right, so there's our sun. How do we just do this? What is going on? What's going on there? Okay, so what's happening? Light rays, like from the sun, come in parallel to the principal axis. So here's our principal axis, and those light rays are coming in.
The sun is so far away, 96 million miles away, that the light rays coming from it are practically parallel.
Yeah, and so it's like those light rays are coming in parallel to the principal axis, and they are reflected through the focal point.
Yeah, and what you did out there is you had that board, and as you moved it back and forth, you got, like when it was too close, you got a big round thing, and then when it was just exactly the right spot, you got all of them focused to this tiny little spot. And that's called a focal point. It's what focusing is all about.
Oh, like on my camera.
That's right.
Right? Okay, so I'm gonna have you guys do this worksheet here. Now, it is a reading comprehension challenge. Can you read?
And you will need a protractor and a pencil.
You will need a protractor and a pencil. And so, I believe in you guys. I know you will find a protractor and a pencil. And follow directions.
Yeah, let me just show them something here. You've got parallel rays coming into the mirror. Here's the center of curvature. This is the center of curvature right here. That's like the center of the sphere. And you're going to measure, well, first, read carefully. You've got ray 1, 2, 3, and 4. And you're going to be measuring angles on one side and then measuring the other and drawing lines. So,
and Boykin, you said this is like this. This is like the sun ray, right?
yeah, the sun's rays coming in.
Coming in, and then this is it.
And what we want to find out is where are they going to reflect. So you'll measure the angle on one side of the radius, this one, and then you'll mark the other side of the radius and draw a line.
And you'll do that several other times, and see what you get. Okay, we'll go over that tomorrow. Okay, what's next? The focal point lies halfway between the mirror and the center of the sphere.
Well, this is what they're going to. Should we show? Should we stop right here and show them what you did on the?
Yeah. We don't have to stop. We can just go over here.
Yeah.
Okay, so let's go ahead and take a look at what it looks like. I was thinking it might be helpful for them to go over it, but okay.
So you've already done the homework.
I have done the homework.
You students have already.
Oh.
We should say stop this.
Oh yeah.
Do
stop,
this.
Stop this. Do the homework. I want a different color here to help accentuate.
Did you get the protractor?
It's right over there.
Gotta have a protractor.
Another protractor. Okay. So here is what I did. So it says for dotted lines, should I just go through it all, Boykin?
Yeah.
Okay, for dotted lines 1 and 3, measure the angle between the dotted line and the radius on the mirror. So I wanted to figure out, this is the sun ray coming in.
Yep.
It's reflected off the mirror. And I wanted to figure out what angle it was coming in at. So what I did was I measured, okay, lining this up right here. Yikes, why is this so hard? Okay. And I measured this angle right here, and it was about 10.5.
10.5 degrees.
So I wrote right here, I said 10.5.
10.5 degrees.
Now the directions say measure an equal angle on the other side, side of each radius, and draw the line from the mirror to the principal axis. So that means I use this as my
That's the radius.
yeah, and then I just lined it up on there, like such. Okay, and again, then I measured 10.5 right here.
Yeah.
Okay, so I put a little dot right there, and it wants me to measure a line from here to there through the principal axis.
Yep.
Okay, so like that. That's my principal axis, right?
Yes,
Okay,
ma'am.
So then next, okay, oh, and do the same thing for 3, right? So here's 3 coming in, right here, right here
Yep.
is coming in, okay? And I wanted to know what this angle right here was.
It's a small one.
And so let me actually put this way. So I just put it on there like that, bada boom. And my measurement was that it was 4. Okay,
4
so I
degrees.
put 4 degrees there. And then I did the exact same thing on the other side of the angle. And I put a dot right there. I said, okay, that's 4. I hope you guys can see this okay. Okay. Okay, and I draw until it passes through that principal axis. And you can see that they crisscross. My lines are not exact here, but right around there, I'm going to say.
And that is the focal point. That's what we saw with the mirror out there in the sun. And that's the focal point. You know what occurs to me? Let me grab a ruler here.
Oh, good idea. So we just said, take a look at the screen again. The focal point.
measure the radius from
Yeah.
here to the mirror. And
I'm
what do
gonna
we
do
get?
it in about 19.5.
And then what's the focal point?
9 3/4.
Okay, so that's about halfway, right?
Yeah.
Which is
Oh, it's right over here. I was
Yeah.
like, look around.
Well-
Yeah. Okay. So the focal point lies halfway between the mirror and the center of the sphere. Boom. Okay. So let's finish this up. So then it says draw the lines from the focus point to the mirror where lines 2 and 4 are.
So what
2
we've
and
done
4.
first is we've come in parallel to the, parallel to the principal axis, and the rays are focused through the focal point. What are we going to do now?
Okay, so now we're gonna go from the focal point to where ray number 2 is, right here. Okay, so focal point here, 2 here. I'm gonna draw that. Boom. Okay, and then
Measure that angle.
and you measure the angle, which I did not do. I can do that now. Okay, so here we go. I was like, yeah, it looks the same to me. Okay, so we'll call. Oh, I'm gonna call it 5. It probably should be 4.
So
but-
5 degrees.
Yeah.
And let's see, what does the lab say? It says,
Okay, it says draw lines from the focus point to the points of the mirror where lines 2 and 4 intersect. Measure the angle between this line and the radius. How does this angle compare to the angle on the dotted line?
well, they should be the same.
Yeah, they should be the same. So if I was to measure this one right here, in the middle, and I get 5 again.
Yep.
Okay, so I'm just gonna do like one of those little like double another.
And what that
things.
is that's the law of reflection.
Mm-hmm.
Because the any radius is going to be tangent to the surface,
Mm-hmm.
which makes it a normal.
Yeah. And then we could do the same thing over here, right? We could draw the line from the focal point to number 4 down here. So I'll just go ahead and do that from the focal point to 4. Okay, and again, I'm not going to, but I could measure this and it would be the same angle as this.
Right.
Okay.
So the point here is that light rays that come in parallel to the principal axis are reflected through the focal point. But if a light ray goes through the focal point, it reflects back out parallel to the principal axis.
That is the take-home message. Did you guys get that? Is that good? Okay.
Well, we'll go over it again.
Yeah, we'll go over it again tomorrow in class. Okay, so we just did this, yes?
Well, we haven't done the last thing.
So if we know that if the focal point lies halfway between the mirror and the center of the sphere, ooh, that rhymes, then we know that the focal point is going to be 6 centimeters.
Half. Yeah.
Oh, great. Okay, so we have an amazing sim, which we will link in for you guys. This is fun, all right? So here's my object, and I can check that. I can move my object, right?
First of all, move it back out.
Right over here?
Yeah. And what we have here is, here's your mirror. Here's the principal axis. Your object is going to be represented by an arrow.
Woohoo!
And the image is also going to be represented by an arrow.
Okay.
And if you grab the tip of the arrow of the object, you can make it taller or shorter.
Oh, I see. Ooh, I didn't know that earlier.
You can make it taller or shorter, and you can move it in towards the...
Oh, and that's what we saw. Okay, so when we were holding our mirror, right, and I was standing at this position right here, we walk forward. Well, the first thing we observe is that I'm inverted, right?
Right.
As I walk forward, we notice that my face got bigger.
Yeah.
Right? So what we notice about this arrow over here is getting bigger. It's inverted, bigger, bigger, bigger. And at some point,
when the object gets to the focal point, all of a sudden, these two lines are parallel.
yes, and there's no image will form, right?
Images are formed where the light rays converge. If they're not converging, no image. So that's why you don't get, you can't see yourself when you're at the focal point.
Yeah.
What happens if you keep going?
How? Or they're behind. They're over here now.
Now the object is behind the mirror, and that means it's a virtual image.
Oh, sorry, I'm not pulling. Okay. And as I get closer, I get smaller and smaller and smaller. Okay, so this is cool. Very cool. Okay.
In fact, you can use this sim to check your work as we go forward.
Yeah, we're gonna leave it up. Okay. All right. So you can see that as the object moves in, the image moves out. Yes.
Yep.
Okay. Compared to the object, the image is either upright or inverted.
So one of the things you're going to have to do is describe the image. And it can be larger, the image is larger or smaller than the object, and the image is either upright or inverted.
Just some qualitative descriptions there. If the image is in front of the mirror, it is real. So we were projecting our image on a screen, right?
Yep.
That means it's real.
Yep.
If it's behind the mirror, it's virtual.
Yeah.
Okay. If the rays converge only behind the mirror, the image is virtual.
That's what you just
Right?
said,
That's what we
yeah.
just said, right? And so when we bring it really close up here in front of the focal point, this is like when you're looking at your makeup mirror,
Yeah.
right? All my boys, you know exactly what I'm talking about. So,
Well, let me say something about this. Notice that the light coming in parallel reflects through the focal point. And so these two lines never converge, they're diverging. You have to draw them backwards, and where they converge, that's the location of the image. It's kind of like what we saw
yeah.
with the plane mirror.
So kind of like this, right? So in and then back and then through the center and they converge back here.
Yep.
Right? Is that right?
Yep.
Okay. All right. That's it.
So basically, what you've got here is, where am I?
Where am I?
Real image. The image is in front of the mirror. Real image, real image, real image. There's the focal point. I got nothing. And then all of a sudden, I'm upright, and that's a virtual image behind the mirror.
And that's it?